Hey guys, this is Coach Lowe, and we're going to talk a little bit about parallel lines and proportional parts. So this is Chapter 7, Section 4. We'll write down some theorems and a few examples and then talk more when you get to class. So parallel lines and proportional parts. All right, so let's get started. All right, so first of all, let's put down Theorem 7.5, triangle proportionality theorem. All right, so this theorem states if a line is parallel to one side of a triangle and intersects the other two sides, then it's going to divide the sides into segments that are proportional, so segments of proportional lengths. So I'll go ahead and draw a picture and then we'll write that theorem out. All right, so let's label this A, B, C, D, and E. And these guys are parallel to each other. All right, so if a line is parallel to one side of the triangle, so I have line BE parallel to line CD, and it intersects the other two sides. So here's the side and that side. So it's intersecting the other two sides. Then it divides the sides into segments that are proportional. So that means AB over BC is equal to this side AE over ED. So the sides are now proportional. So I'm going to go ahead and write this out. If a line is parallel to one side of a triangle, and it intersects the other two sides, then it divides the sides into segments that are proportional. So let's say in this problem that they told us that this was 8, this was 3, this was 12, and this was x. So example 1 here. I have lines that are parallel, they intersect the sides, so I know 8 over 3 equals 12 over x, and then we can solve this. So we talked about shortcuts yesterday. I could cross multiply here, and then I'm going to divide by 8. So 3 times 12 divided by 8. So 36 divided by 8. So x is 4 and 4/8 or 4.5 or 4.5. All right, let's go to the next one. All right, so theorem 7.6 is a converse of the theorem before. So the theorem before we had, if a line is parallel to one side of the triangle and intersects the other two sides, then it divides the sides into segments that are proportional. Now we're going the other way. If a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then that line is parallel to the third side of the triangle. So it's the converse of theorem 7.5. So you should be able to look at what you have for 7.5 and be able to write the converse. Remember, switch the hypothesis and the conclusion. You can also look in your book and copy that down, not a problem. All right, so let's draw a picture of that. All right, so here's my triangle. All right, so now it's if AE over EB equals CD over DB, then AC is parallel to ED. Where before we had if BE, so given, we would have BE is parallel, so that's our if BE is parallel to CD, then this is true. Now we switch that hypothesis and conclusion. All right, so now let's talk about mid-segments of a triangle. All right, so mid-segment of a triangle means that the endpoints of the segments are at the middle or at the midpoint of the sides. So we would find that we talked about this first semester. We actually have this in our notebook. We could find the midpoint. We talked about how to even construct that, didn't we? When we connect those together, we know that this is congruent to this guy is congruent to this guy, excuse me, that guy's congruent to that guy. I went across, didn't I? And this one piece is congruent to this piece. All right, so mid-segment of a triangle is parallel to one side of the triangle, and the length is half of that side. So let me just draw this. So this is parallel to this side, and however long this guy is right here, this guy is half of that. Right, so that green goes with the green. Same thing on this one. This guy right here and this guy right here are parallel. So however long this one is, this one's going to be half of that. And let's go with the red side. So here's my red side. And this one, however long this guy is, this one's going to be half of that. Right? So if they tell me that this side is 12, then I know this is going to be 6. All right, so that's exactly what that means. So I'll go ahead and put some letters on this. Here's A, B, and C. And this is D, E, and F, where D, E, and F are midpoints. Right, so we know that CB, that 1/2 of CB is equal to DE. So whatever CB is, if I take half of it, it's DE. So hopefully that makes sense. If it doesn't, then just put a star by it and we can talk about it some more tomorrow. All right. So let's get the, there's a couple of corollaries, proportional parts of parallel lines and congruent parts of parallel lines. That's in 7.1 and 7.2. If you want to copy those down in your notebook, you might pause the video and go ahead and copy these two things down. So proportional parts of parallel lines says if you have 3 or more parallel lines and they intersect 2 transversals, then they cut off the transversals proportionally. In other words, let's get some parallel lines drawn here. And let's get some transversals going. So these guys are all parallel here. And let's go A, B, C, and D, E, F. All right, so we know that, first of all, AD, BE, CF are parallel to each other. So from there, we know that when I write this, that AB is proportional to, or sorry, AB over BC is proportional to DE over EF. So AB over BC equals DE over EF. So if I'm missing one of those pieces, I'm able to solve and find that. All right, now there's another corollary, and it's 7.2. And it says if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal, which means if I have parallel lines that are basically the same distance apart, right? So I draw parallel lines here and I have a transversal that cuts through, and I'll draw another one here. Their point is that if these segments are congruent, then every transversal that cuts through gives congruent segments. Now this comes into play, it's kind of a cool thing. Because if they give you variables for these two, we could just set them equal to each other. Not a problem. So it looks like this: A, B, C, D, E, F. Now we know that if AB is congruent to BC, so let's go back. If AD is parallel to BE and is parallel to CF, and segment AB and segment BC are the same length, or they're congruent to each other, then we know that DE is congruent to EF. All right, so let's get an example here on this one. Let's say that this is marked just like this, and that this section is 9y minus 2 right here, and this section is 6y plus 4, and this section is 3x minus 7, and this section is x plus 5. So this section was 3x minus 7. It's kind of hard to read on top of that. All right, so these are marked congruent. So I know that 9y minus 2, whatever that length is, has to be equal to 6y plus 4. So I can solve this by subtracting 6y from both sides and then adding 2 to both sides, and I get 3x equals 6, or x is 2. All right, so excuse me, y. Ooh, change variables on us, didn't I? All right, so when I plug in 2 for y, 9 times 2 is 18, minus 2 is 16. I plug in 2 for y here, 6 times 2 is 12, plus 4 is 16. So yep, it checks. Those lengths are both 16. All right, I have x's over here. If I didn't, I could set these equal to 16 because I already know how much it's supposed to be. So I have 3x minus 7 equals x plus 5. Or we could just set one of these, like I said, equal to 16. So I subtract x from both sides and then add 7. So x equals 6. All right, so these are congruent to each other. I think I said set it equal to 16. I totally did not mean that because it doesn't say that these two are congruent to each other. It says they're congruent this way. All right, so x equals 6. So when I plug in 6 here, it should check. 3 times 6 is 18. Minus 7 is 9. And then, does that say 7? Sorry, 3 times 6 is 18, minus 7 is 11, and then 6 plus 5 is 11. Okay, so simple math kind of got me right there. All right, so several things in this. If these are marked congruent, then these are going to be congruent to each other. They will not necessarily be congruent across, so don't be confused by that. Remember, when we worked with parallel lines cut by a transversal before, when we talked about alternate interior angles and things like that, we stayed with one transversal, so stick with the transversal. Don't be jumping back and forth. But if these are marked congruent, then I know that these two segments are going to have to be congruent also. All right, but it doesn't say anything about going across, so don't be crazy and try to stick that on there. All right, so we will work some more example problems when I see you again as we talk about 7-4, and then I'm going to let you get started in class. So hopefully this makes sense. Remember, write down questions that you might have at the end so that you can make sure that you ask about those. And then go ahead and let's see. How about put BAM after, let's go with corollary 7-1 right next to that. Go ahead and put BAM. All right, I'll see you guys. This is Coach Lowe and I'm out.